Welcome to Tomorrow Unveiled, the show that cuts through the noise to bring you what's next. Imagine walking into your kitchen tomorrow morning. There's a robot folding your laundry, not in some fancy demo video, but actually, persistently, learning your home. It knows where you keep things, it understands your routines. It's getting smarter every single day. This isn't science fiction anymore. It's happening right now, and the company making it happen just revealed their third generation robot, Figure Zero 03. And the world absolutely lost its mind. But here's what most people missed. Figure Zero 03 isn't just a robot. It's the physical embodiment of a much bigger shift in AI. It's the moment when artificial intelligence stopped being something that lives in the cloud and started living in your home, in your factory, in your world. Today, we're breaking down everything you need to know about Figure Zero 03, the Helix AI Brain powering it, and the full-blown race to build the first truly general-purpose humanoid robot. We're talking about vision language action models, embodied AI systems, robot manufacturing at scale, and why this moment matters more than you probably think. Let's dive in. On October 10th, 2025, Brett Adcock, Young, the CEO of Figure AI, posted a video that broke the internet. In it, Figure Zero 03 does laundry. It serves tea. It interacts naturally with humans in a home environment. The movements they look genuinely intelligent. But here's what made people really pay attention. Adcock explicitly stated that nothing in the video was teleoperated. No remote control, no puppet strings, no Wizard of Oz effect hiding behind the curtain. Why did he need to say that? Because just a year earlier, Elon Musk had shown off Tesla's Optimus robot at a We Robot event. Dancing, serving drinks, greeting people. Afterward, someone revealed it was actually being remotely controlled the whole time. Musk never really addressed it. Adcock's message was clear. Figure is different. Figure Zero 03 is actually autonomous. So what's changed from Figure Zero 02 to Figure Zero 03? Everything. The company completely redesigned it from the ground up with one singular goal: manufacturability. Nearly every component was rethought. The team ruthlessly cut part count, switched from expensive CNC machining to die casting and injection molding, and rebuilt the supply chain from scratch. The result? Manufacturing costs dropped dramatically. We're talking about an order of magnitude improvement. But there's more. Figure Zero 03 is also 100% lighter and significantly smaller than Figure Zero 02. The hard plastic shell is gone, replaced with soft textiles and strategically placed multi-density foam. It's safer to be around. Less intimidating. More human. The hands are completely redesigned. Each one now has a palm-mounted camera that gives close-range vision when the main cameras are blocked. And the fingertips? They're embedded with tactile sensors, sensitive enough to detect 3 grams of pressure. That's the weight of a paperclip. Think about that for a second. The robot can feel the difference between a secure grip and an impending slip before it happens. The battery is also revolutionary. Figure spent months developing a power system that's dramatically safer than previous generations. Multiple layers of protection, already certified to UN 38.3 standards. And here's the wild part. It supports wireless inductive charging. The robot literally just steps onto a charging mat and powers up. No plugs, no cables. But the hardware redesign is only half the story. The real revolution is what's happening in the robot's brain. Figure Zero 03 was engineered specifically to work with something called Helix, Figure AI's proprietary vision language action model. And this is where things get genuinely innovative. For years, the robotics industry has been stuck in a loop. You want a robot to do something? You either write a script for it, or you collect thousands of hours of human demonstrations. It's expensive, it's slow, it doesn't scale. Helix completely changes that equation. Here's how it works. Inside Figure Zero 03, there's not one brain. There are 3. System 0 handles reflexes and balance. It's trained in simulation, running hundreds of thousands of virtual hours on slopes, obstacles, and interfering forces. When you push the robot, System 0 keeps it upright. It's the nervous system. System 2 is the thinking brain, running about 7 to 9 times per second. It's basically a vision language model living on the robot itself. When you tell it to do something, fold this towel, or load the dishwasher, System 2 understands the scene, understands your instruction, and figures out the high-level strategy. System 1 is where it gets interesting. This runs at 200 times per second. It's the execution layer, translating System 2's decisions into precise motor commands. It's constantly adjusting based on sensory feedback from the hands, the cameras, the tactile sensors. What makes this different from previous approaches? End-to-end learning. All three systems are trained together. The robot doesn't run preset scripts anymore. It learns from video data. And here's the really important part. It learns incredibly efficiently. Figure claims that Helix can master new tasks from just 80 hours of video footage. 80 hours. That's nothing. Traditional approaches need thousands. How? Vision language action models learn the way humans learn. We watch someone do something once, and we understand the concept. We can generalize. We can adapt. VLAs try to capture that same ability in AI. The robot watches humans perform tasks, laundry, dishwashing, organizing, cooking prep, and it builds an understanding of not just what they're doing, but why. What's the goal? What's the strategy? What are the subtasks? Then when the robot encounters a similar situation, it can apply that understanding to new environments, new objects, new variations it's never seen before. This is fundamentally different from traditional robotics, where you need to explicitly program every variation. It's AI that understands context, and Figure is collecting data at scale. They launched something called Project Go Big in September 2025, a massive data collection effort using hundreds of Figure O3 robots working with human pilots wearing VR headsets. The pilots demonstrate tasks. The robots record everything. That data gets uploaded wirelessly via 10 Gbps wave connections, and terabytes of it. Then Helix learns from all of it. Every robot in the fleet benefits from every other robot's experience. It's a shared brain improving constantly. That's the flywheel. And it's why Figure is so confident they can hit their goals. We're not just creating robots here. We're creating embodied AI systems, artificial intelligence that exists in a physical body and learns from physical interaction with the world. This is fundamentally different from ChatGPT or Claude or any other large language model. Those systems are disembodied. They exist in servers. They learn from text and images, but they've never felt anything. They've never manipulated an object. They've never experienced the physical consequences of their actions. Embodied AI is different. It learns through interaction, through trial and error, through sensory feedback. Imagine a Figure AO3 in your home. Day 1. It struggles with your specific kitchen layout, your specific dishes, your specific habits. But every day, it learns a little bit more about your environment. It learns which cabinet doors stick, which countertops are slippery, where you keep things. After a month, it's significantly better. After a year, it's operating with a level of familiarity that rivals a human member of the household. That's persistent robot learning, and it's one of the most important capabilities we're developing right now. Why does this matter? Because embodied AI is how you build robots that actually work in the real world. The real world is messy, unpredictable. Every kitchen is different. Every factory floor has its own quirks. You can't pre-program for all of that variation. But a robot that learns, that adapts, that improves over time, that can handle real-world complexity. This is also why data is so valuable. The company that can collect the most real-world data from the most diverse environments has the biggest advantage. Figure is betting everything on this. They're building a global network of Figure overseers, collecting data from homes, factories, warehouses, everywhere. And here's something important that most people miss. Once a skill is learned by the Helix network, it can be deployed to the entire fleet instantly. Every robot benefits. It's a form of collective intelligence. So if one Figure O3 learns how to fold a specific type of fabric better, every other Figure O3 gets that improvement. That's the exponential advantage. That's how you build a system that gets smarter faster than any individual robot could on its own. Hey, real quick, if you're enjoying this breakdown, do me a favor and hit that subscribe button. And turn on notifications so you don't miss when we drop the next episode. It really helps us out. Now let's talk about how Figure is actually building these things at scale. Here's something that most people don't appreciate about robotics. Building one robot is hard. Building 1,000 robots is so exponentially harder. Building 1,000,000 robots? That's a completely different challenge. For decades, humanoid robots have been engineering prototypes, beautiful, impressive, completely impractical to manufacture. They're hand-built, they're expensive, you can't scale them. Figure looked at this problem and said, what if we redesign the entire robot specifically for manufacturing? That's Figure O3. Every single component was evaluated through one lens. Can we make this at high volume? Can we reduce cost? Can we simplify assembly? The mechanical engineering team was ruthless. They cut part count dramatically. They eliminated anything that wasn't absolutely essential. Figure O2 relied on CNC machining. Expensive, time-consuming, hard to scale. Figure O3 uses die casting, injection molding, stamping, processes that get cheaper as volumes increase. Then there's the supply chain. Figure didn't just work with existing suppliers. They built an entirely new supply chain from scratch. They vertically integrated critical components, actuators, batteries, sensors, electronics, and designed them completely in-house. For everything else, they strategically partnered with suppliers capable of meeting massive volume targets and strict quality standards. The centerpiece of all this is BotQ, Figure's dedicated manufacturing facility. The first generation can produce up to 12,000 humanoid robots per year, with the goal of 100,000 robots over the next 4 years. Everything flows through a custom manufacturing execution system that Figure built themselves. Every subassembly, every component, every final unit gets tracked. Full traceability. Continuous improvement. This is where the competitive advantage kicks in. The company that can manufacture cheaply and at scale, they've got an unstoppable flywheel. Lower costs mean more robots deployed. More robots deployed means more data collected. More data means smarter robots. Smarter robots are more useful. More useful robots sell better. Better sales means more manufacturing investment. And the cycle continues. Figure is betting that they can get there first. And once they do, they'll have such a cost and capability advantage that competitors will struggle to catch up. But manufacturing is just one piece. The real game is happening in 3 specific areas: dexterity, locomotion, and industrial deployment. Here's what separates a robot that can pick things up from a robot that can actually do useful work: dexterity and dynamic locomotion. Let's start with the hands. Figure O3's hands are a massive leap forward. The fingertips have that 3-gram tactile sensitivity we talked about. But it's not just about feeling, it's about control. When you pick up a fragile object, a wine glass, an egg, a smartphone, you're not consciously thinking about grip pressure. Your nervous system just knows. It feels the weight, the texture, the resistance. It adjusts automatically. Figure O3's hands do the same thing. The softer, more adaptive fingertips increase surface contact area. The embedded palm cameras provide redundant vision when the main cameras are blocked. The tactile sensors provide continuous feedback. The result? The robot can handle a much wider range of objects, different shapes, different materials, different fragility levels. In the demo videos, you see Figure O3 picking up a computer mouse with precision, holding a cleaning ball gently, manipulating irregular objects. That's not luck. That's dexterity. And dexterity matters because most real work requires it. Assembly, packaging, food handling, sorting, almost everything humans do with their hands involves fine motor control and sensory feedback. Now, let's talk about locomotion. System 0, that reflex brain we mentioned earlier, is trained for dynamic locomotion. The robot learns to walk, balance, and navigate obstacles through simulation. But here's what's wild. The simulation training transfers to the real world. The robot practices for hundreds of thousands of virtual hours on slopes, obstacles, and interference. Then it gets deployed and it just works. It walks, it balances, it navigates. This matters because homes and factories aren't flat, obstacle-free spaces. There are stairs, uneven surfaces, clutter. A robot that can only walk on perfectly flat ground isn't useful. A robot that can navigate real-world complexity is. The combination of dexterous manipulation and dynamic locomotion means Figure 03 can actually do useful work in real environments, not just in controlled demos, not just in specialized settings, in actual homes and factories. And speaking of factories, that's where Figure is proving this right now. Forget the home market for a second. The real money and the real proof of concept is happening in factories right now. Figure signed BMW as their first major customer in 2024. In April 2025, multiple Figure 02 robots started working on the production line at BMW's Spartanburg factory. 10-hour shifts, 5 days a week. What are they doing? Picking up parts and placing them onto fixtures during live production. Those parts get incorporated into the BMW X3. It's not a demo. It's not a test. It's real manufacturing work. This matters for 3 reasons. First, it proves Figure's robots work in real factories, not just polished demos. The environment is loud, chaotic, filled with variables. The robot has to perform reliably. Second, real revenue, real data. Figure is learning from actual manufacturing conditions. What works, what doesn't, where the failure modes are. That data feeds back into Helix. The next generation robots are better because of this real-world experience. Third, credibility with major manufacturers. When BMW says, yeah, we're using these robots in production, other companies take notice. It's a signal that these aren't experimental prototypes, they're deployable systems. And here's the beautiful part. The industrial market is actually bigger than the home market right now. Manufacturers are desperate for labor. They're willing to pay for solutions that work. Figure 03 can handle repetitive tasks, precision work, and physically demanding jobs. The actuators in Figure 03 can move twice as fast as Figure 02 with improved torque density. That means faster pick-and-place operations, better economics for manufacturers, more attractive ROI. So while Figure is marketing Figure 03 heavily for home use, they're already generating real revenue from industrial customers. That revenue funds development. That development makes the robots better. Better robots make the home market more realistic. It's a two-pronged strategy. Industrial deployment right now, home deployment tomorrow. But there's a bigger question hiding underneath all of this. What happens to human workers? Here's the uncomfortable truth nobody wants to talk about. Robots are going to replace workers. But, and this is important, that's not necessarily bad. It depends on how we manage it. Figure AI frames their robots as workforce augmentation tools. The idea is that robots don't replace humans. They work alongside humans, handling the physically demanding or repetitive tasks, freeing humans up for higher value work. It's a nice framing, and there's truth to it. A factory worker using a Figure 03 to handle dangerous or repetitive work? That's an improvement. That's augmentation. But let's be real. Some jobs will disappear. The question isn't whether robots will impact employment. They will. The question is how we manage that transition. We're talking about potentially billions of robots in the workforce, doing work every day. In manufacturing, logistics, healthcare, food service, agriculture, everywhere. That's not a small shift. That's a fundamental restructuring of the global labor market. Figure's CEO, Brett Adcock, is at least honest about this. He's talked about the need for universal basic income. He's acknowledged that as robots become more capable, we'll need new social structures to distribute the benefits. But whether society actually implements those structures, that's a policy question, not a technology question. What's clear is that the robotics industry doesn't care about the policy question. They're focused on making robots better, cheaper, and more capable. The societal implications are someone else's problem. So here's what actually matters. The first company to build truly general-purpose humanoid robots at scale will have enormous power. Not just economic power, real power, over labor markets, over employment, over people's lives. Figure is racing to be that company. And they're not alone. Figure AI isn't alone. Not even close. There's a full-blown race happening right now, and it's being called the physical AI race. Tesla's working on Optimus. Boston Dynamics partnered with Toyota on humanoid robots. Unitree in China is rapidly improving their designs. 1X Technologies in Norway is building NEO. Aptronic is working with Google on humanoid robots powered by Gemini. There are dozens of companies competing. But here's what makes Figure different. Figure is the only company betting everything on the home market right now. Everyone else, Boston Dynamics, Tesla, Unitree, they're focusing on industrial applications first. They think the home market is years away. Figure is saying the home market is now. And they're betting billions on it. They're also ahead on the AI side. Helix is their own proprietary vision language action model. They're not relying on OpenAI or Google. They've built the entire stack in-house, hardware, software, manufacturing, data collection, and they're moving fast. Figure O2 launched in 2024. Figure Y launched in October 2025. That's less than 2 years between generations. They're iterating rapidly. The competition is fierce, though. Tesla has enormous resources and manufacturing expertise. Boston Dynamics has decades of robotics research. Chinese companies like Unitree are moving incredibly fast with lower costs. But Figure has something unique. They have the most capital, the most ambitious vision, and the most aggressive timeline. Brett Adcock said in July that general robotics would be solved within 24 months. He revised that to 18 months. Is that realistic? Probably not. But the fact that he's saying it, and the fact that investors are backing him, tells you something about the momentum in this space. This is the physical AI race, and it's not just about robots. It's about which company will own the future of labor, manufacturing, and domestic life. But before we get too caught up in the hype, let's talk about what's actually real and what's marketing. Here's what they're not showing you in those polished demo videos. During Time magazine's visit to Figure's headquarters in August 2025, they witnessed multiple demonstrations where the robot failed. A Figure So2 dropped laundry on the floor and couldn't pick it up. Another one struggled to fold a t-shirt. When it actually worked, that was news. Figure's CEO acknowledged the limitations. "We want the robot to be able to do most things in your home, autonomously all day," Adcock said. "We're not there yet. We think we can get there in 2026, but it's a big push." 2026. Not now, not next month. 2026. And even that is optimistic. The robot still struggles with basic tasks. Folding a towel successfully, even some of the time, is considered impressive in the robotics industry. The reason? Fabric is unpredictable. Every crumple is different. Every material behaves differently. Figure is collecting data from human pilots wearing VR headsets to train Helix. They're building a massive data set. But data alone isn't enough. Some roboticists, including Rodney Brooks, the co-founder of iRobot, argue that you can't teach dexterity without being able to measure touch sensations. Brooks wrote, "Simply collecting visual data alone can't possibly be enough to infer how to be dexterous." He called it probably dumb and an expensive mistake. Figure disagrees. They believe that vision language action models can learn dexterity from video alone, supplemented by their tactile sensors. Who's right? We don't know yet. Figure will find out when they try to scale this. There's also the question of safety. Figure O3 is designed to be safe. Soft materials, multi-density foam, limited strength. But the real challenge is the decision-making. The AI has to make safe choices. Adcock says that getting a robot to be extremely safe in the home long-term is maybe one of the hardest problems we face. He's testing Figure O3 in his own home with young children, subject to what he calls hardcore babysitting. That's not exactly a rigorous safety testing protocol. There's also the data question. Figure plans to use data from home robots to train future models. They say they'll scrub personal information, blur faces, replace identifying details, similar to how Google Street View works. But the reality is messier. Homes contain intimate details, financial information, health information, medical equipment. The privacy implications are significant. So here's the honest assessment. Figure 03 is impressive. The technology is real, the progress is genuine, but it's not ready for widespread home deployment yet. The company is being optimistic about timelines. The safety and privacy questions are still being worked out. But, and this is crucial, none of that means it won't happen. The trajectory is clear. The technology is improving rapidly. The capital is flowing. The timeline might slip, but the direction is inevitable. We're at an inflection point. For decades, robots have been specialized tools. A robot that assembles cars can't fold laundry. A robot that picks packages can't cook dinner. We've accepted this as inevitable. But what if You could build one robot that does everything. What if that robot got smarter over time? What if it could work in your home, your factory, your office? That's what Figure 03 represents. Not the finished product, but the proof of concept. So what does this all actually mean for you? Let's zoom out and think about what this actually means. We're watching the emergence of embodied AI, artificial intelligence, that exists in the physical world and learns from physical interaction. This is different from everything that came before. Large language models are powerful, but they're abstract. They manipulate text and images. They don't manipulate the world. Embodied AI systems like Figure 03 are different. They perceive the world. They act on the world. They learn from the consequences of their actions. That's a fundamentally different capability. When Figure 03 picks up an object, feels it with its tactile sensors, and adjusts its grip, it's learning. When it drops something and has to figure out how to pick it up, it's learning. When it fails at a task and tries a different approach, it's learning. That's real intelligence. Not simulated intelligence, not pattern matching, real embodied physical intelligence. And here's what makes this moment special. We finally have the AI capability to make this work. 5 years ago, vision language models weren't good enough. 3 years ago, they were getting there. Today, they're genuinely impressive. Combine that with the hardware advances, better sensors, better actuators, better batteries, and suddenly humanoid robots become practical. Add in the manufacturing innovation, Figure's ability to build these things at scale, and suddenly it's not just possible, it's inevitable. So what happens next? That depends on execution. Figure says they can have home-ready robots by 2026. Maybe they're right, maybe they're optimistic. But the direction is clear. Within a decade, it's plausible that there are millions of humanoid robots deployed globally, in factories, warehouses, homes, hospitals, working, learning, getting smarter. What does that mean for the economy? For employment, for society? Honestly, we don't know. This is uncharted territory. But we do know this: the company that gets there first, that builds the most capable, most reliable, most widely deployed robot, will have enormous power, not just economic power, real power. Figure is racing to be that company. They've got the capital, the talent, the vision, and the momentum. Their competitors are coming too. Tesla, Boston Dynamics, Chinese companies, they're all moving fast, but Figure is moving fastest. And they're betting everything on being the first mover. Will they succeed? Will they deliver on their promises? We'll find out, and soon. If you're watching on your phone, there's a hype button right below the video. Smashing that really helps smaller channels like ours get discovered. Thanks for watching. See you next time on Tomorrow Unveiled.